Hi everyone, my name is Han Lin, and I'm gonna do the question 1 of homework 3, so let's begin. So it tells us that the probability of x equals to k equals to b times k times k minus 1th power of p. So for the subproblem A, it tells to find b so that the probability of x equals to k represents a probability mass function, and it is only satisfied if and only if the summation equals to 1. The summation is k from 1 to infinite. So we just put a b out. So we have this equation, b times the summation equals to 1. So all the thing we have to do is to calculate the summation, but it is really hard to directly calculate it. So instead, we consider another summation, the summation of kth power of p from k equals to 0 to infinite. So we expand it, it equals to 1 plus p plus the p square plus blah 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 blah. We suppose it equals to a, and we times p on both sides because we know p is larger than 0, so it's safe to just times p on both sides. So the left side is p times a, and the right side we times p to every term, and equals to p plus p squared plus p cubed plus blah blah blah. And we use the first equation to minus the second equation. So the left side it is a minus p times a, and on the right side everything except for this one is eliminated, p squared. So only one left. So we have this equation a minus p times a equals to 1, and from that we can derive that a equals to 1 divided by 1 minus p. And so we have this summation now. So we only have to transmit the summation to this summation, k times p, k minus 1's power of p. So we can say that it is actually, this summation is the derivative of k's power of p. So we calculate the derivative on both sides. So the left side is the derivative of the summation of k's power of p, and on the right side we simply calculate the derivative of 1 divided by 1 minus p. So on the left side, the derivative is actually just this summation, the summation of k times the k minus 1th power of p, and it equals to the result of this derivative. It is 1 divided by the 1 minus p squared. So from that we have already got this the value of the summation, so we substitute it into it. So we have b times 1 divided by 1 minus p squared equals to 1. Then we got the result of b, it equals to the square of 1 minus p. So that's the subproblem A. So for the subproblem B, we have to calculate the expectation of x. So from the definition of expectation, we know that it equals to the summation of k times the probability of p x equals to k. So we substituted the p x equals to k into it, and of course we substitute the b's value into it, and we drag it out. So it equals to 1 minus p squared times the summation, and still we have to calculate the summation, and we can find that it is the derivative of this summation, and this summation is this summation times p. So simply we can just times p on both sides from this equation, and we can get this equation like the summation of k times the k squared of p equals to p divided by 1 minus p squared. So we use the same setup. We calculate the derivative on both sides. So on the left side, it is the summation of k squared times the k minus 1th power of p, and on the right side is the derivative of this equation, and equals to 1 plus p divided by 1 minus p's cube. So here we can derivative like so we do get this the value of the summation, and we don't have to care about the k equals 0 situation, because when k equals 0 is actually 0. So we substitute the summation's value into it. It is so it is 1 minus p squared times 1 plus p divided by 1 minus p's cube. So the final result is 1 plus p divided by 1 minus p. So for the subproblem C, we use the same plot, so use the same method, but the expectation of the x squared is equals to k squared times the probability of it, and we have this equals to 1 minus p squared times this summation. And this summation is actually a derivative of k squared times the kth power of p, summation of it. And this summation is times, it can be derivative from this equation, like it times p on both sides. So we use the same method here, and we do have this summation k cube plus multiplies by k minus 1's power of p, it equals to the derivative of this term, and the result of this derivative is p squared plus 4 times p plus 1 divided by 1 minus p, the fourth power of 1 minus p. So we substituted the result into it, so we got the final result that the expectation of x squared is equals to p squared plus 4 times p plus 1 divided by the square of 1 minus p. So that's the result of the x squared's expectation. So for the subproblem D, we simply use the result of the subproblem B and subproblem C. We substitute the result into it. So it equals to this equation, and equals to 2 times p divided by the square of 1 minus p. And for the subproblem E, we have the actual value of p, it equals to 1 times 3. That's what it gives us. So we can calculate the b, it equals to 4 divided by 9, and we substitute b into it. We have the probability of px to k's equation, and then we can calculate like px equals to 2, px equals to 3, px equals to 4, and px equals to 5. We all got the exact number of it, so we calculate them. And we do have the probability of x larger or equal to 2, or then smaller or equal to 5. It's just a summation of this 4 probability, like px equals to 1 plus px equals to 3 plus px equals to 4 plus px equals to 5. And the summation of them is actually 392 divided by 729. And it tells us to calculate a conditional probability. We just use the definition of conditional probability. So the probability of so the probability of x equals to k under the condition x larger or equal to 2 and smaller or equal to 5, it actually equals to the intersection of px equals to k and px equals larger or equal to 2 and smaller than equal to 5, and divided by the probability of x larger or equal to 2 and smaller or equal to 5. So because it is a discrete random variable, so we can just simply discuss when x equals k and k equals to a different situation. So we can just calculate it. It is like px equals 2 divided by px this, and divided by the probability condition, and px is 3, x4, x5. So actually it is the condition of x k equals to 1. This is k equals to 3. This is the k equals to 4, k equals to 5. So we have value for this four case values, but and we have 0 when k equals to other numbers, otherwise. So that's all for the question 1. Thank you.